OSPF version 3 address families topology. And you need to connect a switch, connect other device in the gigabit 00. Otherwise, the interface will not be completely enabled. Okay, and these are my interfaces, and in my case, instead of using serial 000, I'm using serial 30. Instead of using serial 001, I'm using serial 31. Instead of using serial 010, I'm using serial 32. Suggested stubby configurations. Okay, configure these basic settings. Very useful. Paste in all devices. Start all devices. R1. Configure terminal. Right click to paste. R2. Configure terminal. Right click to paste. R3. R4. Set the host name. Exit host name R1, R2, R3, and R4. Configure the addressing and serial links. Using the topology, configure the IPv4 and IPv6 addresses on the interfaces of each router. For example, on R1. Gigabit 0, IP address, IPv6 address, link local, global unicast address, no shutdown, exit, serial 0, in my case serial 30, okay, the connection to R2, okay, this interface IP address 2.1, 252, subnet mask, same link local address on IPv6, and the global unicast is 2.1. Clock rate no shutdown. R2 configurations. Exit, interface, gigabit 00, IP address, IPv6 address, 2 as the link local, global unicast, no shutdown, exit. Serial 0 and serial 1, in my case serial 30 and serial 31, serial 30 and 31, 30 connection to R1, 31 connection to R3, the IPv4 2.2, 252, same link local address for IPv6, IPv6 global unicast subnet number 2 and second IP, no shutdown. Serial 31, IPv4 on subnet number 4, first IP 252. This is the connection to R3. Same link local address, global unicast on subnet number 4 and first IP. Clock rate no shutdown. R3 addresses, exit interface gigabit 00, IP address 5.1, subnet mask 24, okay, is the gigabit interface, IPv6 address, link local 3, link local, global unicast, Subnet 5, first IP, prefix 64. Shut down, exit. Serial 1 and serial 010. In my case, serial 1 is serial 31 and serial 010 is serial 32. Serial 1 and serial 32. IPv4 address, subnet number 4, second IP 252, link local, global unicast, subnet 4, second IP, no shutdown, exit. Okay, serial 32. The IPv4 address is 77.2. Subnet mask 24. Same link local address. Global unicast. Correct. No shutdown. Exit. Finally configure R4. Exit. Serial 0, in my case is serial 30. IPv4 address. IPv6 address, link local. Global unicast. First IP. FEED77, first IP. No shutdown. Exit. Gigabit 00. IPv4 address 99.1. Subnet mask 24. Link local address. Global unicast. 99.1.1. And shut down. Okay, on R4 enable an IPv6 unicast routing. Exit IPv6 unicast routing. Create a static route to reach the subnets on R1, R2, and R3 using the NetHub IP address placed on serial interface on R3. Okay, on R4, create a static route to reach the subnets on R1, R2, and R3 using the NetHub IP address. Create an IPv4 default route using the NetHub IP address. Verify connectivity. Use the show IP interface brief command and show IPv6 interface brief command. For example, go to R1 and show IP interface brief. Okay, two interfaces, very well configured and up. Ping the neighbor R2. 192.168.2.2. Success. Go to R2 and show IP interface brief. Okay, three interfaces very well configured and up. Ping R3. 4.2. Success. And finally go to R3 and ping the R4 verify show IP interface brief. Okay, three interfaces up, ping R4 192.168.77.1. Success. Verify IPv6, repeat, but show IPv6 interface brief. Okay, very good. Two interfaces and ping ping R2 subnet to IP second IP. Success. R2 show IPv6 interface brief. Okay, very good. Ping R3 4.2 column 2. Success. Go to R3. IPv6 interface brief. Okay, very good. Three interfaces configured up. Ping to R4. Success. Configure and verify OSPF version 3 address families for IPv4 and IPv6. OSPF version 3 with the addresses family AF unifies OSPF configuration for both IPv4 and IPv6. OSPF version 3 with address families also combines neighbor tables and the link state database under a single OSPF process. OSPF version 3 messages are sent over IPv6 and therefore requires that IPv6 routing is enabled and that the interface has a link local IPv6 address. This is the requirement even if only the IPv4 address family is configured. After configuring the OSPF version 3 address family, the show OSPF version 3 command should use it to verify the OSPF router ID for both the IPv4 and IPv6 address family. If the OSPF router ID is using a 32-bit value other than the one specified by the router ID command, you can reset the router ID by using the clear OSPF version 3 process ID process command and re-verify using the command show OSPF version 3. After enable IPv6 Unicode routing, configure the OSPF address family on R3 using the router OSPF command. The mark question is used to see the two address families available. Okay, go to R3 configure terminal IPv6, unicast routing, router OSPF version 3, process 1. Okay, address family mark question dash, okay, space and mark question. Okay, you can create address family for IPv4 and IPv6. Enter IPv4 address family configuration mode using the command address family IPv4 unicast. The mark question is used to examine the options in the address family configuration mode. Some of the more common configuration commands are highlighted. Use the router ID command to configure the router ID for IPv4 address family. Okay, address family IPv4. Okay, IPv4 unicast. Okay, this is the address family configuration mode, and use the mark question. You can configure the area, the autocast, the default information, the distance, default metric, the interface ID, the passive interfaces, redistribute, router ID. Okay, set the router ID for R3. Okay, the passive interface on gigabit 00 on R3. Okay. Exit the IPv4 address family configuration mode and enter the IPv6 address configuration mode. The exit address family, or a shorter version of exit command, is used exit address family configuration mode. Issue the address family IPv6 unicast command to enter the IPv6 address family. For the IPv6 address family, use the router ID command to configure the router ID and the passive interface command to configure gigabit 00 as a passive interface. Although it isn't necessary, a different router ID is being used for IPv6 address family. The exit command is used to return to global configuration mode. Okay, exit from IPv4 address family, exit address, okay, dash family. Okay, and enter to address family IPv6 unicast. Set a router ID 3336, passive interface gigabit 00, and exit to address family, and exit from address family. Okay, finally exit from router configuration mode. OSPF version 3 is enabled directly on the interfaces for both IPv4 and IPv6 address families using the OSPF version 3 process ID, IPv4 or IPv6 area and area ID interface commands. Use this command to enable OSPF version 3 on both R3's interfaces on area 0. Okay, remember that R3 has two interfaces on area 0, serial and gigabit. Do not configure the connection to R4 to OSPF. Okay, interface gigabit 00, OSPF version 3, process 1, IPv4 area 0, and IPv6 area 0. Exit. Serial 1, this is the connection to the connection to R2. Okay, in my case, serial 3.1. OSPF version 3, process 1, IPv4 area 0, and IPv6 area 0. Exit. Okay, go to R2 and configure all these similar process like R3. But remember, router R2 is an area border router, so be sure to configure the proper area ID to each interface. The OSPF process ID does not need to match other routers. Okay, because it's locally significant. Okay, remember that R2 is an area border router because it has area 51 and area 0. Okay, and configure terminal. Don't forget to enable IPv6 unicast routing. IPv6 unicast routing. Now, router OSPF version 3, process 1, the address family for IPv4 unicast, the router ID, the passive interface, gigabit 00, exit from IPv4 address family, and configure IPv6 unicast address family. The router ID 2226, passive interface, exit from router configuration. Okay, and remember that on R2, serial 0 on area 51 in serial 1 and gigabit 00 on area 0. Okay. Interface serial 3.1, OSPF version 3, process 1, IPv4 area 0 for serial 1, OSPF, okay, and IPv6. Okay, look at this. The neighbor adjacency with R3, the neighbor is R3 for IPv4. Okay, enter this command for IPv6, also on area 0. The neighbor adjacency for IPv6 and the R3 router ID for IPv6. Okay, gigabit also on area 0 for IPv4 and for IPv6. And finally, serial 0 on area 51. In my case is 3.0. The area for IPv4 is 51 and the area for IPv6 also 51. Okay, no neighbor adjacency messages because R1 is still not configured. Okay. R1 on area 51. Remember, on R1, all interfaces placed on area 51, the serial interface and gigabit interface. Configure terminal. Don't forget to enable IPv6 unicast routing. Router OSPF version 3, process 1, space, okay, the address family, IPv4 unicast, the router ID, the passive interface, exit from address family configuration mode. For IPv6, router ID 1116, passive interface, exit from address family and exit for router configuration mode. Go to interface gigabit 00 and apply OSPF version 3 process 1 IPv4 and on area 51. Okay, IPv4 on area 51 and IPv6 on area 51. Go to serial 0, in my case serial 30, enable IPv4 on area 51, get the neighbor adjacency with R2, and for IPv6 also on area 51. Okay, in the neighbor adjacency with IPv6 with R2. Verify that the routers have OSPF version 3 neighbors. Okay, for example, go to R2 and show IP OSPF neighbor. Okay, no neighbors. Okay, but if you will use IPv6, you have two neighbors, R3 and R1. The local ID is this, process ID 1. Why doesn't the show IP OSPF neighbor command display any output? The show IPv6 OSPF neighbor command is used to display OSPF version 2 neighbor adjacencies. R2 has been configured using OSPF version 3, so no neighbors adjacencies are displayed. Why does the show IPv6 OSPF neighbor command only displays OSPF version 3 neighbors in the IPv6 address family? The show IPv6 OSPF neighbor command is used to display OSPF version 3 neighbor adjacencies. Specifically for IPv6 indicates by the IPv6 keyword in the command. The router ID 1116 and 3336 are associated with the IPv6 address family. Issue the show OSPF version 3 neighbor command. Show OSPF version 3 neighbor. Now you can see the IDs for IPv4 and IDs for IPv6. The local ID for IPv4 and the local ID for IPv6. The IPv4 and IPv6 routing tables can be verified by using the show IP root and show IPv6 root commands. Each router should see all IPv4 networks and IPv6 prefixes in the OSPF routing domain, including those with passive interfaces. Okay, for example, go to R1 and show IP routes. Okay, 2 directly connected networks and 3 OSPF inter-area routes. Okay, 3 placed on gigabit 0 on R2, 4 placed between R2 and R3, and 5 placed on gigabit 0 on R3. show IPv6 routes. Okay, 2 directly connected networks, 3 routes for OSPF inter-area 3, 4, and 5. R2 show IP routes. 3 directly connected networks, and intra-area number 1 placed on area 51 on gigabit 0 on R1 and 5 on gigabit 0 on R3. Show IPv6 routes. Okay, 3 directly connected networks and 2 intra-area routes. R3 and show IP routes. 3 directly connected networks, 2 inter-area OSPF and 1 intra-area OSPF. The number 1 is placed on gigabit 0 on R1. Number 2 placed between R1 and R2. And number 3 placed on gigabit 0 on R2. Okay, very well configured. Understanding the difference between commands associated with OSPF version 2 and OSPF version 3 can seem challenging at times. The show IP route OSPF version 3 command is used to view OSPF version 3 routes in the IPv4 routing table. The show IPv6 route OSPF command is used to view OSPF version 3 routes in the IPv6 routing table. The show IPv6 route OSPF command is the same command used with traditional OSPF version 3 for IPv6. Okay, for example, show IP route OSPF. Okay, now output show IP route OSPF version 3. The IPv4 for OSPF version 3. IPv4 for OSPF version 3. Show IPv6 route OSPF. Route. Okay, the IPv6 from OSPF version 3. IPv6 from OSPF version 3. Why doesn't the show IP route OSPF command display any routes? The show IP route OSPF command is used to display OSPF version 2 routes in the IPv4 routing table. R3 is using OSPF version 3. Configure IPv4 and IPv6 default routes on the autonomous system boundary router R3 for forwarding traffic to R4. Propagate both default routes into OSPF version 3 within the appropriate address family. Okay, configure all this in R3. Configure terminal IPv4 default route quad 0 using the NAT hub IP address, the serial interface on R4, and IPv6 default route using the NAT hub IP address, the serial interface on R4. Okay, a default route on R3 and the NAT hub IP address serial interface on R4 for IPv6 and IPv4. Go to router OSPF version 3, process 1, the address family on IPv4, unicast, default information originate, exit from address family, IPv6 unicast, default information originate, exit, and verify on R3, show IP route, okay, the static default route, show IPv6 route, the static default route to for IPv6. Okay, R1 show IP route, the default route E2 OSPF external type 2, show IPv6 route, the default route R2, show IP route, success, show IPv6 route, success, configure an IPv4 and IPv6 static routes on the autonomous system boundary router R3 for the 99 for IPv4 and 99 for IPv6 networks on R4. Redistribute the static route into OSPF version 3, IPv4 and IPv6 address families using the redistribute static command in each address family configuration mode. On R3, configure terminal. Okay, IP route 99.0, subnet mask 24, netscope IP address 77.1. And for IPv6, (99.1) 64, netscope 77.1. Okay, redistribute router OSPF version 3, process 1, address family on IPv4, redistribute static, exit from IPv4, IPv6 unicast, redistribute the static and exit, and okay, verify on R3, show IP route, the static route, show IPv6 route, the static route, go to R1, show IP route, okay, this E2 OSPF IPv6 success R2 IPv4 success IPv6 success. Configure an OSPF version 2 stub area. Under OSPF version 3 process for R1 and R2, For both the IPv4 and IPv6 address families, configure area 51 as a stub area using the area stub command. The adjacency between the two routers might go down during the transition period, but it should come back afterwards. Okay, on R1, configure terminal, router, OSPF version 3, process 1, address family, IPv4, unicast, area 51, stub. Okay, exit from address family and go to IPv6, area 51, stub, and exit from address family. Also on R2, configure terminal, router OSPF version 3, process 1, router OSPF version 3, process 1, address family IPv4, unicast, area 51, stub. Okay, exit from address family IPv6, unicast, area 51, stub, and exit. And confirm that both R1 and R2 are neighbors for IPv4 and IPv6 address families using the show OSPF version 3 neighbors. Show OSPF version 3 neighbors. Okay. For IPv4, R3 and R1. For IPv6, R3 and R1. Issue the show IP root OSPF version 3 and show IPv6 root OSPF commands on R1. Notice that R1 still has a default route pointing toward R2 but with a different cost that it had prior to being configured in a stub area. This is not the default route propagated by the autonomous system boundary router R3, but the default route injected by the area border router of the stub area. R1 also does not receive any external routes, so it no longer has the 99.0 or the 99 networks in its IPv4 and IPv6 routing tables. Stub routers continue to receive inter-area routes. Go to R1 and show IP route. Okay, this is the show IP route on R1 before the stub area. The default route, the cost is 1, 2 directly connected networks, 3 inter-area OSPF, and 1 E2. Okay, but now there is only inter-area default route. Okay, and the cost is 65. Only 1, 2 directly connected networks, and 3 inter-area OSPF routes. IPv6 route. Okay. before a stub area, the default route, the static route propagated by R3 two directly connected networks, 3 inter-area OSPF routes. Now, only a default route, inter-area 65 cost, 2 directly connected networks, and 3 inter-area for OSPF. R2 show IP route. Okay, it still has the E2 type for OSPF and the static. Okay, on R2, the show IP route. Okay, this is the configuration for show IP route before to configure the stub area. Now the routing table is the same because this is the area border router. The same case for IPv6. Before the routing table is the same routing table because this is the area border router. Be the output of show OSPF version 3 command on area border router R2 to see what type each area is and the number of interfaces in each area. Prior to issuing this command, notice the show IP OSPF command displays no output. Once again, this command is for OSPF version 2. We are using OSPF version 3. The show IP OSPF version 3 command may seem like a logical alternative. However, it is not a legitimate option. OSPF version 3 is a single process for both IPv4 and IPv6 address families, so the correct command is show OSPF version 3. This will display OSPF version 3 information for both address families. Okay, for example, on R2, the area border router show IP OSPF. Now output show IP OSPF version 3. Invalid input, okay, should be show OSPF version 3. Area backbone 0, 2 interfaces, area 51 with 1 interface. This is the stub area and generates a stub default route with cost number 1. OSPF version 3 process 1 for IPv6, the address family, local ID, backbone 0, area 0, 2 interfaces, area 51, 1 interface. Its stub area generates a stub default route with cost 1. Configure a totally stubby area. Remember that a totally stubby area is a modified version of a stubby area. A totally stubby area border router only allows in a single default route from the backbone injected by the area border router. To configure a totally stubby area, you only need to change the command at the area border router R2 in this scenario. Under the router OSPF version 3 process, you will enter the area 51 stub no summary command for both the IPv4 and IPv6 address families to replace the existing stub command for area 51. The no summary option tells the router that this area will not receive summary inter-area routes. To see how this works, issue the show IP route OSPF version 3 and show IPv6 route OSPF commands on R1. Notice the inter-area routes in addition to the default route generated by R2. Okay, before to configure the totally stubby area, show IP route on R1 or simply show IP root OSPF version 3 and show IPv6 root OSPF. Okay, look at the output of the show OSPF version 3 database command on R2 to see which link state advertisements are in its OSPF version 3 database. Notice that both the IPv4 and IPv6 address families link state advertisements are in the same link state database. You will also notice OSPF version 3 changed the names of two types of link state advertisement and added two others. For comparison of OSPF version 2 and OSPF version 3, link state advertisements go to this side, okay? And go to R2, show OSPF version 3 database. Okay, for area 0, router link states, inter-area prefix link states, link type 8 link states, intra-area prefix link states, and for area 51, router link states, inter-area prefix link states, link type 8 link states, intra-area prefix link states. Finally, type 5 autonomous system external link states. And the same case for IPv6 database. Okay. Finally, configure the totally stubby area on R2, the area border router. Configure terminal router OSPF version 3 process 1, address family IPv4 unicast area 51 stub with the no summary keyword. Okay, it's a stub. Okay, exit address family. Okay, family. The same process for IPv6 unicast area 51 stop now summary and exit address family and go back to R1 and issue the show IP root OSPF version 3 and show IPv6 root OSPF commands. Notice that both routing tables only show a single incoming route from area border router R2, the default route. The default route is injected by the area border router R2. There are no inter-area OSPF version 3 routes and no external OSPF version 3 routes. Okay, go to R1 and verify show IP root OSPF version 3 and show IPv6 root OSPF. Okay, for IPv4, before totally stop area, 4 routes, but now for IPv4 you have only inter-area OSPF route, the default route. And for IPv6, before 4 routes and after only one, the default route. Go to R2 and verify again the database. Show OSPF version 3 database. Okay, basically the same database, but now show OSPF version 3. Show OSPF version 3. For IPv4, the backbone 0, 2 interfaces, but for area 51, 1 interface, a stub area with no summary generates a stub default route with cost 1. And for IPv6, backbone 0, 2 interfaces, and area 51, 1 interface, a stub area, no summary, generates a stub default route with cost 1. Why does R2 generate a stub default route into area 51? Is this the default route advertised by the autonomous system boundary router R3? R2 is generating the default route into area 51 because it is an area border router and the area 51 has been configured as a totally stubby area. The default route is not the route advertised by the autonomous system boundary router R3. Okay, R2 show IP protocols. Okay, OSPF version 3, process 1. Show IPv6 protocols. IPv6 routing protocol, OSPF process 1. Is there any information in the output of these commands that indicate gigabit 00 is passive interface? No, the output shows no information for passive interfaces. Okay, show OSPF version 3 interface gigabit 00. Is there any information in the output of this command that indicates gigabit 00 is a passive interface? Yes, no hello's passive interface. Okay, this command no hello's passive interface. No hello's passive interface. Why are there two sets of output for gigabit 00 interface? One set of output is for OSPF version 3 IPv4 address family, and the other set is for the IPv6 address family. Notice the different router IDs that were configured for each address family. Okay, for the router ID for IPv4 and the router ID for IPv6. Thank you very much.